Welcome you all to the video lecture on signal synthesis. Today we are going to discuss about the cascade and parallel form realization for the given different equation. So this topic comes under the block diagram representation. So actually block diagram representation is one which gives a pictorial representation of the given system. So this is the equation what they have given y of n minus 3 by 4 y of n minus 1 is 1 by 8 y of n minus 2 that is equal to x of n. So let us see first the cascade form realization. So what do you mean by cascade form realization? Cascade form realization is one where you are going to split your transfer function into multiple sub-transfer functions. Okay, that is if given your h of z, we are going to split this into multiple transfer functions. H1 of z into h2 of z into h3 of z and so on. It will be going on. Okay. And finally, what we are going to do means we are going to draw the direct function structure for h1 of z, direct function structure for h2 of z, h3 of z, so on, and connect all the realization, direct form to realization structure in series manner, or we can say that it as a cascade manner. Okay. So cascade form realization is also called as series form realization because we are going to connect all the subtransfer function in series manner. Okay, so for that first what we are going to do, let us consider the given equation y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 that is equal to x of n. So to obtain the transfer function h of z, okay, we are going to apply first z transform. In some problems they may give directly the h of z. Okay, so we can factorize directly that given h of z into subtransfer function. Here h of z is not directly given, the given is a difference equation. So apply z transform and find out the h of z, that is transfer function first. So apply z transform for the given equation. So y of n becomes y of z minus 3 by 4 y of n minus 1. The z transform of y of n minus 1 is z for minus 1 y of z. So whenever I have minus 1 here, you will get z for minus 1. If you have minus 2, it will become z for minus 2 y of z. Okay, so the third term is 1 by 8. Since it is minus 2, it is z power minus 2. Y of n, we can write it as y of z. Here, right hand side, we have only x of n. That we can write it as x of z. So, taking y of z commonly outside. So, 1 minus 3 by 4 z plus 1 by 8 z power minus 2 x of z. Therefore, the transfer function h of z is given by y of z by h of z, output by input. So y of z by x of z, plus x of z to the left hand side. So numerator is 1. So denominator to right hand side, you get 1 minus 3 plus 1 by 8 z power minus 2. So this is h of z. So next step, we are going to split this term h of z into multiple of subtransfer functions. Okay. So the higher power term here is z power minus 2. So we can factorize this term and we can find out two factors for the given transfer function in the denominator. Okay. So what we are going to do means first h of z is 1 by 1 minus 3 by 4 z inverse plus 1 by 8 z power minus 2. So split this term into two subtransfer functions since we have z power minus 2. Suppose if the given equation, if we have z power minus 3, then we can split that into three subtransfer functions. That is h1 of z, h2 of z, and h3 of z. But here it is z power minus 2, so we can split this as h1 of z into h2 of z. So for that we have to factorize what are all the terms available in the numerator Anyway, numerator we have only 1, so we can keep 1 as it is. The denominator we have to factorize. Use your calculator and factorize your term. So what do you have to do? Uh, uh, Press mode, go to equation, press right arrow, you will get that degree. Okay, and then press degree. So under the degree, you have to give, because the degree here, that is our term, is nothing but 2. Okay, so we have to give degree 2. So what are the coefficients here? We have 1, a value is 1, b value is minus 3 by 4, c value is 1 by 8. So give like that. Okay, so a value is 1, b value is minus 3 by 4, c value is 1 by 8. So in the calculator, you'll be getting 2 values. So what are all the values available? So one you'll be getting 0.5, another you will get as 0.25. So if it is so, how we can write this expression? So since here first term is 1, okay. When you multiply two terms, I should get first term as 1. So always this term will be 1. Okay. So this term will be 1 by b. And then whatever the value you are getting here in the calculator. Okay. So for plus 0.5 you are getting, you have to write it as minus 0.5. Similarly, plus 0.25 means we have to write it as minus 0.25. Okay. Or else easy way. So what is 1 by 8? So when you multiply, you should get 1 by 8. When you add, you should get minus 3 by 4. So 3 minus 1 by minus 1 by 4. So when you multiply, you'll get plus 1 by 8. When you add these two terms, you'll get minus 3 by 4. So either you can go by this method, or suppose if it is tough for you, you can use your calculator and factorize your terms. Okay. So one term, here it is plus 0.5 plus 0.25. So while writing in the factors, we have to change your sign and write 1 minus 0.5, 1 minus 0.25. And then here z power minus 2 we have, right? So that we have to split into two terms. One z inverse we have to use here, one z inverse we have to use here. Okay. So suppose if we have z power minus 3 term, we will be getting 1 minus z inverse terms 3 times. Okay. So 3 times we will be having terms in the denominator. So as I said, this is nothing but your h1 offset into h2 offset. So how I can split this term? One term as 1 by 1 minus 0.5 z plus, another term 1 by 1 minus 0.5 z. So here this is nothing but h offset. This is nothing but h offset. Okay. So draw the direct contours. Why we are going to use direct form 2? Direct form 2 is again a simple and forward easy realization, and also we can reduce the number of delay elements. Okay, when compared to direct form 1, the number of delay elements is less in direct form 2. So for implementing your cascade and parallel form, we will be using direct form 2 structure. So we are going to draw the direct form 2 structure for H1 offset and H2 offset. So draw the direct form 2 structure for H1 offset. So how will you draw? H1 offset is 1 by 1 minus 0.5 z. So since when we compare both numerator and denominator, only one z inverse is available. So put that in the middle. Numerator always in the right side. So first line with 1. Denominator always in the left side. As I said, the first term is always 1. So write first line with the 1. Denominator you have to always reverse your direction. That is minus 0.5. Okay, since we are reversing the direction, it will become plus 0.5. Okay, so remember that numerator in the right side we have to draw, denominator in the left side. Numerator always in forward direction, denominator always in the reverse direction. So always change the sign. Okay, so these are all the hints for easy drawing. Okay, here direct form 2 structure. Numerator, here I have only 1. So first line with 1 I have drawn. Denominator, first term always it will be 1 in the forward direction, right? Other terms whatever available in the denominator, you have to reverse your direction and also change your sign. So Z inverse into actually minus 0.5 will become plus 0.5. So these two terms are added. So put one added. Okay. So since this is H1 of Z diagram, will be X1 of Z and output will be Y1 of Z. Okay. So this is the direct form to structure for H1 of Z. Okay. So once you have drawn this, we have to draw the diagram for H2 of Z. So what is H2 of Z? 1 by 1 minus 0.25 Z. So how will you draw? Again, when you compare both numerator and denominator, here Z inverse only one Z inverse is there. Numerator always in the forward direction. So I don't have Z inverse term. So first line it will be of 1. Here denominator, I have first term always 1 in the forward direction. Second term or other terms in the denominator, whatever available, you have to reverse your direction and change your sign. So since minus 0.25 you have, it will become plus 0.25. Both the terms are added, so put one adder. Use up arrow. So this is x2 of z and output is y2 of z. Why? Because this is direct form structure for h2 of z. So once done with both the diagrams, we can combine or connect both subtransfer function in series manner. Okay. So how to draw your cascade form? Just draw both the diagrams as it is. So as how the diagram is, draw the diagram as it is. So this is for the first term. So for the second term we have like this. Okay. Finally connect both the diagrams. Okay. So once you have drawn this output, okay, so here we have one. So this is the first diagram, this is the second diagram. So first diagram I have x1 of z, y1 of z, here x2 of z, y2 of z. So connect the output to the input of the second diagram. So just connect this line as it is. Okay. So this is the first diagram, this is the second diagram. Connect the output of the first diagram to the input of the second diagram. So the final output will be y of z, final input will be x of z. So this is the cascade form realization for the given h of z. So just find the subtransfer function, draw the diagram in direct form true structure for both the subtransfer function, connect it in the cascaded manner. So if it is parallel form, for parallel form realization, we have to split the given transfer function into addition of subtransfer function. Thus, the given h of z, we have to write it as addition of subtransfer function like h z plus h2 of z plus h3 of z and so on. So previously cascaded form means multiplication of subtransfer function. Parallel form means addition of subtransfer function. So for parallel form, since we are going to convert the given transfer function into addition of subtransfer function, we have to always apply partial fraction method. So in simple, you can remember P for parallel, P for partial fraction. Okay. So whenever you have parallel form realization, by default you have to apply the partial fraction. So what is the given h of z? Already we have defined the h of z. It is 1 by 1 minus 3 by 4 z inverse plus 1 by 8 z power minus 2. And we have obtained the factors also, right? So numerator it is same as it is 1, and denominator we can write it as 1 minus 1 by 2 z inverse, or we can write 1 minus 0.5 z inverse, right? That is what we have obtained. So either you can write in the fraction manner or decimal point values. So 1 minus 0.5 z inverse into 1 minus 0.25 z inverse. So use your calculator and factorize. So this step already we have done. Okay. So we need to apply the partial fraction for this. So since you have two terms, I can write it as a by 1 minus 0.5 z inverse plus b by 1 minus 0.25 z inverse. Okay. So when you compare the left hand side with the right hand side, right? Left hand side numerator I have 1. So how will you write a into? So here already 1 minus 0.5 z inverse is available. So other term is minus 0.25 z inverse. Okay. So when you compare this denominator term with this term, there already 1 minus 0.25 z inverse is available. So other term is b into 1 minus 0.5 z inverse. Okay. So always compare your denominator with this. So when you compare this, already this term is available. The other term is just multiply that. Similarly, when you compare this term with this, already 1 minus 0.25 z inverse is there. This term is not available. So multiply with that. Substitute your z inverse such that either one term get cancelled, so that other term we can find out. Okay. So what we can substitute here, we can substitute, since we have 0.25, we can substitute it as 1 by 0.25. So what happens? 1 by 0.25 means 0.25 get cancelled, 1 minus 1 it will become 0. So this whole term becomes 0. Like that you can do. So suppose if we have minus here, we will be substituting 1 by 0.25, 1 by plus 0.25. Suppose if we have plus here, okay, we will substitute 1 by minus 0.25. Okay, so change your sign and substitute such that the terms get cancelled. So similarly here also, already we have minus 0.5. So definitely we have to substitute what? 1 by plus 0.5. Okay. So when you substitute this term, z inverse equal to 1 by 0.25, 1 equal to, anyway this term get cancelled, only b we can determine. So 1 minus 0.5 into 1 by 0.25. So this term 0.5 divided by 0.25 is nothing but a 2. Okay. So 1 equal to b into 1 minus 2 is minus 1. So b value is minus 1. And then here 1 equal to, when you substitute 1 by 0.5, second term get cancelled, only first term is available. So a into 1 minus 0.25 into 1 by 0.5. Okay. So 0.25 divided by 0.5 is nothing but 1 by 2. So a into 1 minus 1 by 2 I have. So 1 minus 1 by 2 is nothing but 1 by 2. So what is a? A is nothing but 2. So we have determined a value as 2 and b value as minus 1. So we can substitute in this term and we can find out what is h of z. Okay. So we can finally rewrite your expression as h of z is equal to 2 by 1 minus 0.5 z inverse minus 1 by 1 minus 0.25 z inverse. Okay. So this term is looking like that, h1 of z plus h2 of z, right. So we can easily write h1 of z as 2 by 1 minus 0.5 z inverse, and h2 of z is minus 1 by 1 minus 0.25 z inverse. Okay. So first let me draw the direct form 2 structure for h1 of z separately, h2 of z separately. So for h1 of z, how will you draw the direct form 2 structure? So when you compare both the term, here the common term is nothing but z inverse, right. So only one term is available, z inverse. So put 1 z inverse. Numerator is 2, that you have to draw in the right side, denominator in the left side. So denominator always 1 in the forward direction, other terms in the reversal direction, and change your sign. So reversal direction means 0.5 plus 0.5 and put the adder. Okay. So this is x1 of z and this is y1 of z. Similarly, draw the direct form 2 structure for h2 of z. Only one delay element available, that is z inverse. Numerator we have only minus 1, write as it is. Denominator, first term always it will be 1, always it in the forward direction. Other terms in the reverse direction, change your sign. So minus 0.25 it will become plus 0.25. So meaning that here we have minus 1, here 1, here 0.25 into z inverse. Since you have reversal sign, it is minus 1. So put one adder because these two terms are in addition. This is x2 of z and output is y2 of z. Again, since we have h of z is h1 of z plus h2 of z, the final diagram for parallel form we have to connect in parallel form manner. So draw the two diagrams in parallel manner. So draw h1 of z as it is. So 2, 1.5. Draw h2 of z now. Minus 1, 1.25. Right. So this is h1 of z, this is h2 of z. So we have to connect it in the parallel means connect the input, okay, using a common line, and the common input is x of z. Okay, just connect both the lines and you can put it as x of z. For the output, since both the terms are in addition, okay, if we have two terms, put one adder. Okay, if we have three terms, put two adder. Like that we have to use for connecting the outputs. So put one adder, connect both the outputs, and commonly you can put the final output as y of z. Okay. So this is the parallel form. Series means in cascade manner you have to connect. Parallel means one below the another transfer function you have to draw and you have to connect it in a parallel manner. Connect all your inputs and put it as x of z. While drawing the output lines, we have to use the adder, okay, and then give the output line y of z. Okay. Thank you. Thanks for watching.